So, how did this homework assignment go? Better than the last one? A little bit easier now that you've gotten used to working with pointers a little bit? All right. So, let's look at the solution to this. You were to update your linked list with a method called add@index. And add@index should work for adding things anywhere in your list. And we decided that for this particular one, if they give you a number of 0 or less, you would add to the front. If they gave you a number of the length or higher, you would add to the end. Otherwise, you were adding in the middle, right? All right, so let's deal with the simple cases first. So if index is less than or equal to 0, that means that they want to add to the front of the list, correct? Well, so we'll say this dot add front payload. I already have a method for adding to the front. Might as well use it. Else if index is greater than or equal to this dot count. This dot add end payload. Make sense? So dealt with the easy cases. Else we need to add somewhere in the middle. So if we're going to add somewhere in the middle, that means we're going to do the add here. So we're going to need to create a new node. Node n is equal to new node made out of payload. So that's the node we will be adding. Now we need to go and figure out where we're going to put it. We know if we are in here that index is between 1 and count minus 1. Correct? We know it's somewhere in there. So that means that if we look at our picture here, if this is our current list, then we have a new guy, 6, that we want to add at position 1 here. That means we want this guy to become the new position 1, which will put this guy to position 2. So ultimately we want to hook it up like that. That's what we want it to ultimately look like, right? But initially, we don't have that luxury without just breaking our list. So in order to replace this guy, we noticed that we needed to manipulate the pointer from the guy right before it. So we need to walk. To replace node 1, I need to walk to node 0. That make sense? So what we're going to do is we're going to create cur node and have it pointing at head. And then we're going to traverse index minus 1 times. So if I said 1, I'm going to traverse 0 times. If I said 2, I'm going to traverse 1 time. So 2 would get cur to here, which then allows me to update pointers for bucket 2. So we'll start with that. Have a for loop. Well, actually, we want to say node cur is equal to head. So we'll have cur point to the same place the head points to. Then we'll have our loop for int I is equal to 0. I is less than index. I plus plus. Each time through, we'll set cur equal to cur dot get next node. So this is going to run through 0 or more times. Remember, for loops are pre-check loops. So this is not guaranteed to run even once. If index was 1, this is going to say, is I equal to 0? And actually, I'm lying here. I'm going to say minus 1. Is index equal to 0? Or starts off at I is 0? Is 0 less than index minus 1? If index was 1, 1 minus 1 is 0. Is 0 less than 0? It's not. So we will not do anything in here. which means cur currently points to head, which is exactly where we want it to point to if we are replacing this node, the node at bucket 0, with this node. So we need to traverse to the node right before it. If index was 2, meaning I want to get to here, our loop is going to start off, is 0 less than 2 minus 1? 1? Is 0 less than 1? Yes, it is. So we'll say cur is equal to his own next node. Now I is 1. Is 1 less than 2 minus 1? It's not, it's the same. So we're done. We've moved cur to where it needs to be. All right? So once we have cur where it needs to be, now we get to hook some stuff up. So cur is currently pointing where we want it to be. Here's the new node n that we want to insert into our list. Well, what do we need to do? We need to set cur's next node equal to this guy. But if I do that right off the bat, I've broken my list. So instead, what do? We set cur's, well, let me ask you this question. What needs to happen here? We need to set this guy equal to who? Who should this guy ultimately point to when all is said and done? Cur's next node. So we're going to set n's next node equal to cur dot get next node. So they both point to the same place. Make sense? So we'll say n dot set next node is equal to cur dot get next node. So n's next node points to the same place as cur's next node points to. N's next node points to the same place as cur's next node points to. Both these arrows are pointing to the same place. Make sense? Then we're going to say cur dot set next node to n. Which does this. So now head now points to our new node that's at bucket 1. The old bucket 1 is now at bucket 2, so on and so forth. Make sense? Now let's back up for a second here. Let's say that we were trying to place it at index 1, this guy. Okay? So now, let's say we were going to place it at index 2. So we're going to actually have to traverse once. So index minus 1 is 1. Is 0 less than 1? It is. So set cur to his own next node. Now cur points there. I becomes 1. Is 1 less than 1? No. So we're done. We've traversed as far as we're going to traverse. What does our code say to do first? So this is our traversing. We've moved cur into position. What does this guy say? It says set n's next node equal to the same thing as cur's next node. So that says set this guy's next node equal to that guy, cur's next node. All right, fair enough. Then what does it say? It says set cur's next node to n. This is cur. Here's his current next node. Now we're going to point it to n. So our list looks a little wonky, but it works. Head points to here, this guy points to here, this guy points to here, this guy points to here. So this is bucket 0, this is bucket 1, that's bucket 2, the location of our new node. Make sense? Does this solve the problem? Let's say we wanted to place it here. So let's back up here. So this is 0, 1, 2, 3, 4. So I want it to be the new 4. We're not adding it to the end. We're adding it to the one right before the end, right? So that means it doesn't, since the size of this guy, or was it count? We called it count. Count would be 5 in this case. There's 5 nodes in this list, right? So count is 5. is 4 greater than or equal to 5? It's not. So we won't just trivially add to the end. Where are we at here? We won't just do this guy. We won't just trivially add to the end. So instead we're in the else. We'll create our new node. We'll set cur equal to head. And now we're going to go forward 3 times. I starts off at 0. I keeps going as long as it's less than, in this case, 4 minus 1. So 3. So here's cur. Is 0 less than 3? Yes. 1 less than 3? Yes. 2 less than 3? Yes. 3 less than 3? No. So we stop right there. Then we set cur's, well, we set n's next node to be the same thing as cur's next node. That guy. Then we set cur's next node to be equal to n. Here's head, which points here, which points here, which points here, which points back here, which points to here. Make sense? This is 0, 1, 2, 3, and here's our new bucket 4, which links to now bucket 5, and our count should still be 5. Why? Because I have not updated add front and add end, we already have updated. Add front, count plus plus. Add end, count plus plus. But now I have this add end index. The if and the else if here are already handled because they're calling add front and add end, which do update the count. But in my else here, after I've added something, I need to say this dot count plus plus, indicating that I have in fact added something. This is a point to be careful though. We don't want to just globally say this dot count plus plus because I've definitely added a node. Because if I got into this if or this else if, either of these, I'll increment count by 2. Because add front already increments it by 1, add end increments it by 1, and now I'm just globally incrementing it again. Does that make sense? So I only want to add something to count in the event where I locally did the addition. Otherwise, I will allow add front or add end to increment by count because they're the actual guys who are adding the node to the list. So now as we have it written, the list will update in terms of its length correctly. Make sense? So we'll go ahead and test this in driver. Let's see, what do we have for our current current list looks like this, 2, 3, 7, 4. So let's go ahead and add something at bucket 0, which you call add front, right? So we'll add an index. Let's add a -4 at index 0. So now our new list should start with a -4. Okay. Similarly, I could say add -4 at index -1000, which is a number that's less than or equal to 0. So giving our catch-all, we just go ahead and add it to the front, right? So we said we're going to talk about exceptions today, correct? So we want to be able to yell at them and say, okay, something went south. Similarly, if this is our current list, let me just comment this out real quick. So this is our current list. So this has a count of 4. So if I say I want to add something at bucket 4, it should put it at the end. Correct? So I'll add a -4 at position 4. And now our list ends with a -4. Similarly, if I try to add a -4 to position 4000, it will also add it to the end of our list. Still at -4. All right. Comment that back out. Back to our original list. Let's say I want to add something at bucket 1. So I want it to become this guy. So I want to add a -4 at position 1, which should produce a list 2, -4, 3, 7, 4. So -4, I want him to become the new -1, or the new position 1. There's our -4 at position 1. If I want it at position 2, there it is at position 2. Position 3, there it is at position 3. And we've already seen what happens when we try position 4. Make sense? Questions about this? All right, so that was the homework assignment. How many of you felt this assignment, even though it was more complex than the previous assignment, actually came easier because you'd already had some experience in working with the lists? A couple of you. How many of you felt it was substantially harder? Thought it was substantially harder? Okay, do you know why? Do you have a theory as to why you thought it was harder? I mean, it's fair. I mean, certainly as we draw these lines, things get a little wonky, right?
I think I just kept getting confused with it when I drew it out, and then when I went back and put it in wrote up the code.
Okay, but you did draw the pictures?
Yeah.
Okay, and did you draw the pictures? Okay.
I'd have something to do at work.
Oh, that's fine. So, you know, keep practicing drawing those pictures and it will become easier. Okay, hopefully you've seen from some of the other audience members here that, you know, I think you were a good example. He texted me all excited like, oh my gosh, this assignment was easy. You know, when add end was add end or add front? Add front.
Add front.
Which should have been trivial, right? Add front's like super easy. It's like worked for it on it for hours. And how long did you spend on this one?
Like an hour and a half.
A lot less time with a lot less trouble, right? Okay, so that's your natural progression. Is you're going to get better and better at this. And eventually you'll be able to just sit down, draw the picture, and write it, and it'll work the first time or the first time and a half. You might have a little bug or something, and then you go back and make the quick little change, like, oh, what was I thinking? You know, that type of thing. So that's your natural progression, which is a good thing. All right, now, before we get into exceptions and remove methods, I want to introduce an industry standard tool to you. And this is actually going to be an interesting experiment because I've never actually used the Eclipse plugin for this, but I'll try to introduce it anyways. How many of you have heard of a tool called GitHub? Okay, several of you. Okay, GitHub is something that you will be using, well, that's an industry standard. I'll talk about it and what it does here in a few minutes. If you've ever applied for an internship or a job application or something like that, or set up a profile on some coding websites, sometimes they ask you for your GitHub ID. Okay? So GitHub is the name of the website. So it's github.com. Now, Git is a technology. Git is for what's called version control. So the idea is that when you have a large software application that you're making changes on through over a year's period of time. So, you know, you release version 1 of it, and, you know, that's out there in the wild, and people are putting in bug reports and stuff like that. You go back and you make some changes. The idea might be that you may want to know how you got to today's version from the original version, because maybe you had to make 30 changes in the middle, right? And if we're just updating a Word document, so let's take this away from programming and think about this in terms of a term paper or something like that. When you update a Word document, you go through, you proofread it, you make your spelling corrections and stuff like that. Not that often do we necessarily go back and say, oh, what did I change since last time? Make sense? Because usually you're writing your 2 or 3 page papers to submit the next day or something like that. Or for most of you, probably later on this morning. Or you're working on it today and it was due yesterday. One of the two. All right. Now, but let's say you were an author and you were writing a book. So 300, 400, 500 pages. Probably not something you just sat down and typed out in a single sitting or in 2 sittings, right? Like you might work on your papers for 1 or 2, 3 sittings, something like that. That might be kind of a common term paper for a 2 or 3 page paper type setup. And you're probably sitting there watching TV and maybe even playing a video game, being extra productive, right? Okay, so, but if you're an author and you're writing a book, might you write chapter number 3 2 or 3 different times? Or portions of it 2 or 3 different times? Or you might go back and decide, this character didn't develop the way I wanted this character to develop, so we're going to actually write him out of the book. Or we're going to add another character into the book to make the storyline flow better or something like that. So would you agree that a book, I mean, we're not authors, or at least I'm not an author. Some of you might be aspiring authors. Who knows? But as human beings, we can certainly understand that a book is kind of a living entity that kind of evolves over the however much time you're working on it, right? So it might be helpful to be able to go back and look at older versions of the book, correct? Okay. Similarly, if you're a real author, you might have an editor that's helping you with your book. That editor might be writing portions of the book for you. If it's like a co-author, I guess in that case that wouldn't be an editor, it'd be a co-author. But an editor might be going through and making changes to the book. Some of these changes are going to be grammar, spelling error type changes, which you probably want. Other ones may actually change the structure of a paragraph. Maybe that's not what you want. Okay? So as the author, if you're all working on the same living document, you might want to know who changed what. Because now we have 2 or 3 people working on the same document. The editor made some changes. Your co-author has added a paragraph to page 4 of chapter 2. That kind of stuff, right? So at that point in time, you kind of have 3 documents, okay? 3 branches of this document. The one that was the original branch that you started. Then what's called the fork of that branch, which is the one that your editor took your original, created a new branch that said, here's the original with my changes in it. And then maybe your co-author is working with their own branch that is starting with the original and having their own changes in it. Okay? Now, at some point in time, we're going to say that the author is actually the boss of this whole thing, right? So they're going to look at their original, they're going to look at the editor's changes, they're going to look at the co-author's changes, and at some point they might say, okay, this all looks good. Let's go ahead and merge these together into back into a single branch. Okay? If we're connecting this back to software, we often see this. If you go and download an application, sometimes they'll say, here's the stable release, and here's the beta version. I almost guarantee that's being hosted on GitHub, and there's 2 branches. There's the stable branch, which is the one that's released to the public, and then there's the beta branch, the one that is currently under development. Use at your own risk. Okay? And then there's probably the alpha branch, which is all the crap that's currently happening that hasn't been accepted into the beta branch. Okay? That's the one you probably definitely don't want to use. Okay? The beta version of some of the software is probably okay to use for the most part because at least it's been looked at and said, okay, we think these are good additions, so we're going to go ahead and merge them into the beta branch, and some people will be testing the software associated with the beta branch for a while. And as soon as we give that the thumbs up, what we do is we merge the beta branch into the stable branch. Okay? So Git is a tool for version control. So back to our author example, the author, the editor, the co-author, each of those guys they'd be working on the document locally on their machine, locally on their computer. And then they would use this tool called Git to push stuff up to, in this case, GitHub. Okay, so GitHub is a piece of software, it's a website that was written in terms of the Git tool so that it functioned as a central repository for your code. Okay? Now, so when the co-author first sat down and he didn't have the original copy of the book, what he would initially do is he would do a pull from GitHub using the Git tool. He would pull the current branch of the book. That was his local copy of the current branch that he was going to make changes to. And as he made changes to that local copy, he could then commit those changes back to GitHub using the Git tool. So GitHub is a collection of all the different versions of that document that have ever existed with notes. Because when you commit a change, you might put a little comment saying, I changed up paragraph 2 of chapter 3 to read a different way, or something like that. You put a little comment with it. So the author eventually is going to go into GitHub and say, okay, well, here's a submitted change. This was a committed change from my co-author. Am I okay with this? If I am, I want to go ahead and merge it with my version of chapter 3, something like that. Okay? And when you do the merge tool, it'll show the two things next to each other and say, okay, well, when we merge them, it's going to look like this. And you can kind of adjust how you want it to merge. And do you want it to replace a paragraph in one of them versus the other? Do you want to keep both? That kind of stuff. Okay? So merging requires a little bit of adult supervision to make sure it's doing exactly what you intend for it to do. If you both have a version of paragraph 1 of chapter 3 and you like the co-author's version better, you don't want to have two paragraph 1s. You want to replace the stable branches, the official version of the book's paragraph 1 with the co-author's, overwriting yours. And now that becomes the new stable branch. That make sense? Okay, so Git and GitHub, which is kind of the industry standard repository for Git, before GitHub existed, people could run their own Git servers. They would create their own repository somewhere. There was 50 different tools you can use for this. Everybody in there, a lot of different companies, a lot of different individual developers were writing their own Git repository tool. So we can say that GitHub is a Git repository. Okay? Repository being collection of changes. Many pieces of software today, Xcode being one of them for Apple software development, Visual Studio also has it, does a local Git repository so that you can roll back to previous versions of your code. So it says, okay, well, chances are you're probably the only developer on this, right? So as I've kind of explained this so far, I've said Git's really a collaboration tool. Okay, it's so that multiple authors, multiple developers, whoever, multiple workers on a document can work with this independently of each other and make sure they're not stepping in each other's feet, stepping on each other's toes, feet, toes, heads, stepping in each other's heads. In any case, that's what the tool was probably originally designed for. But even as an individual developer, have you ever been working on a project, made a bunch of changes, saved the document, then realized that you kind of like the old way you did it? And you can only hit undo so many times in a row before you realize you can't get back to the old version? It certainly either happened to you, or we can at least imagine that it could happen, right? So having a local Git repository can help us with that. We can go back in, and instead of having to hit undo a bunch of times until we finally get to the version we wanted and maybe not even know, if it's a 30-page document, well, where was the change? At what point am I stepping back one too far? That type of thing. Well, with GitHub, or with a repository, let's leave GitHub out of it for a second. GitHub, we're going to call it as our industry standard repository now. But with a Git repository, you can go in and you can look at every version of that document that's ever been committed. Pick the one you like, roll back to that one. That makes sense? So it keeps track of every single change that you've ever made. Think of committing a document to a repository as saving. So if you're working with a tool, and we'll see how Eclipse's plugin works for this, because like I said, I've never used it. I've always used Git from the command line. And I'll show you that version of it as well. But if you are working locally in Visual Studio and you hit save, chances are, especially if you're working with Visual Studio's automatic connection with GitHub, it will not update GitHub until you specify that you want to commit your changes. You might sit down for 2 hours, work on this project, and decide, you know, what I just did in the last 2 hours is a pile of crap. It's not done yet. I'm not going to commit those changes for public consumption. All right? Now, public consumption doesn't mean that somebody's going to be downloading it from the beta, but if you're part of a large group of developers or a large group of authors working on something, you might not want to make your current crappy code available to them for review because it's not ready to be reviewed. Make sense? You're going to go ahead and keep it local until you feel that it's ready to put up into the repository. Now, that's one way of doing it. Another way might be to say, I use the repository as my backup. Sure, it lives locally on my computer, but I want it to actually also be up in the repository in case something goes wrong here. Now, an interesting thing that's happened over the last several years as we've gotten various cloud storage things like Dropbox is the idea of something like GitHub gets a little blurred. Why shouldn't I just use Dropbox rather than GitHub? Now, what's Dropbox? Dropbox is a local directory that lives on your computer that whenever you save something in there, it automatically updates to the cloud, keeps the cloud in sync with your local copy. If you're a single developer working on a project and you always keep your projects in the Dropbox folder, so whenever you save, you know you have a duplicate copy in the cloud, that's all fine and dandy. Now you have a backup of your local copy in case something bad happens. So, given that example from a few minutes ago where I said, let's say you just worked on your project for 2 hours and nothing good came out of that 2 hours of effort, or at least it's not done, you're not ready to commit anything, you'd still like it that if your laptop was destroyed later on today, you haven't lost your work. They're going to be upset enough that you've lost your laptop, right? Okay, but you prefer not to also have lost your work. That's the reason to keep something in like Dropbox. Keep your code always in Dropbox so that when you save, it's synced to the cloud automatically. Dropbox is not a replacement for a tool like GitHub. Okay, Dropbox is a second backup. It's a copy. GitHub is a collaboration tool, but it's also a tool specifically for, now let's pull it away from authors and say it's really specifically for programmers. Okay, there are other central repositories. For instance, Google Docs has something built into it that is kind of for people who are sharing a living document, who are all working on it at the same time. Well, they'll kind of show you some things. Tools that make more sense for books and documents like that as opposed to programming. GitHub is really specific for software. So its merging tools, its commit tools, things like that really lend itself to managing a software project. So when you commit something to GitHub, it's not a replacement for Dropbox. Dropbox is a backup tool. GitHub is a version control tool that allows you to roll back and see multiple copies of the same file. Now, Dropbox has a feature you can pay for called PackRat. And the Dropbox PackRat feature, what it does, and I suspect it actually probably uses some sort of Git repository or something like this type thing. What it does is it keeps every version of every file that's ever existed in your account. So if you have a paper you've been working on, and you've saved that paper 25 times, you'll have 25 copies of that paper in Dropbox. Make sense? But each copy isn't a full copy. It's written in terms of the previous copy. So it just keeps track of what the changes were. So when you go to view that document, it merges it in real time and shows you what that version of the document looks like, based on the changes you had made since the previous version of the document. But in any case, Dropbox has this feature called PackRat that will allow you to roll back to an older version of a file if you want. So that maybe gets a little bit closer to a tool like GitHub, but it's still not a replacement. All right? GitHub is focused for people who are sharing source code amongst each other. That could be for collaboration, but it could also be for your own backup of it, and also a way for you to distribute your software to other people. So let's say you're working on a project, and you're going to say it's an open source project. You would love to make this available to the public, if they're interested. Okay? GitHub is free. So anything you put on GitHub will get put underneath a public link. Now, people aren't going to probably stumble upon your code. You'd have to give them the direct link to it, the github.com/your username / the name of the repository you created. Maybe you create a repository for homework 3. If you see where we're going with this, okay? When you commit stuff to that repository, now what you can do is you can submit a link to that repository. When I click on it, it'll open up in GitHub, and I can actually view your code in GitHub. This becomes more and more handy as we have multiple files associated with our projects. In the early days, when you only had driver.java and you were just submitting that one file, no big deal. But as our projects get more and more complex and we bring more and more objects into it, having that repository that allows me to easily look at all the projects instead of you having to, all the files, instead of you having to zip up the source folder and stuff like that, starts becoming handy, not just for you, but also for me. Okay? So do we kind of understand what Git and GitHub are at the high level? Okay? So it's a really important tool, and it's definitely an industry standard in software. So understanding this tool will be beneficial. So let's look at this from a couple different angles, and then we will throw our hat into the plugin ring. So if you go to GitHub's website, github.com, github.com, you can go ahead and create an account on here. It's a free account. There are, it'll always try to have you, do you want to upgrade to a paid subscription, blah, blah, blah. The paid subscriptions, all that lets you do is keep your software up there privately. So people can't see it unless you share it with them. Okay? So if you were working on the latest, greatest version of a top secret piece of software you intend on selling, probably don't want to make that publicly available, because then people have access to your source code. At that point, it might be worth paying the $8 a month for up to 5 repositories or something like that, whatever their deal is. But for most of us, your homework number 3 isn't something that is going to be mission critical if somebody steals it, right? Or they're not stealing it. They won't take it off your GitHub, but they could copy it. All right? So not mission critical, so we're going to use the free account. Okay, we don't care if we're making this public. So you'll create your account, and it'll look like this once you're logged in. So I'm logged in under my account right here. And I actually have my business account on here as well, which we pay for, but that's why it's in purple, but whatever. Okay, so here are kind of they call it the GitHub Bootcamp, how this works. Most of this is command line. So I'm going to take you through that process first. So what I'll do is I'm going to go into Eclipse real quick, and I am going to right-click on the source folder, and I'm going to say, open this in new window. That's not what I wanted to do. Close that. Oh, actually, Eclipse does create a local Git repository. So they're keeping your backups for it locally for you regardless. But what I want to look at it in is probably, is it Navigator, Project Explorer, Systems Explorer. I bet you that opens it in Finder. Yeah, this is good. Okay, so by doing that, it just opened it up in my directory structure, so I had access to it. What I'm going to do real quick here is I'm just going to open up Terminal. So for Windows users, this would be the DOS prompt. Now, most of you do not already have Git installed. If you're a Mac user, you do. Git is installed by default on the Macintosh. But we're not talking about a major ordeal to install Git. All right, you can install it on the PC. But just to make this easy, I'm going to go ahead and hit CD space. And if you didn't know you can do this on the Mac, you can drag a folder out here to the terminal, and it'll go ahead and fill in the full path to that. So I didn't have to write all this crap. All right, so now I'm in that directory. Make sense?
Like that.
All right, so I'm sitting in the .java directory. I'm sitting in the directory with my .java files in it now. You can CD into those directories if you want, whatever. I'm going to say I hopefully will ultimately be showing you a tool that will allow you to do all this stuff from within Eclipse. But I want to show you how Git is supposed to work for most developers so you appreciate what it's doing, and then we'll see how well the built-in remote Git thing works for Eclipse. I actually suspect there might even be something built into it without adding a plugin, but whatever, we'll see in a minute. All right, so at this point, I've opened my terminal. I have moved into the directory where the files that I would like to commit, well, first I'd like to add them to a repository, then I'd like to commit them to the repository. So that's where I'm sitting at right now. I haven't created a repository. I haven't linked this to that repository. I haven't done anything. Make sense? So we're going to leave this right here, go back to the website, going through this bootcamp thing. So the first thing is set up Git. So this is for those of you who do not already have Git on your machine. So you can go through this, download and install the latest version of Git, blah, blah, blah. You can do a git config global username. So once you have it installed, you only have to do these steps one time. Okay, I'll go ahead and do them on this computer so you see it. So what you're doing is you are telling your version of Git who you are, because it will use the who you are and what your email address is for every communication it ever uses with any Git repository. Understand that the tool Git communicates with Git repositories. It doesn't only communicate with GitHub. GitHub happens to be the most popular Git repository. Okay? They called it GitHub because it's a repository for Git. All right? These guys were not born on the same day. GitHub came out years and years and years after Git came out. Before that, there was a whole bunch of third-party repositories that worked or whatever, but people ended up liking this whole web-based thing, and it was good for collaboration and all this other crap, and you'll kind of see that. But I'm going to go ahead and I'm going to steal this line of code, go back to my terminal here, make this a little bit bigger, and I'll paste it in there. And then I'm going to go make a little change. Put my name in there. So, command I'm typing in here is git. So that's the program I'm calling. I'm calling its config program. I'm going to set a global variable. The name of the variable is user.name. And I'm setting it to this string by Clipman. Okay? You don't need to understand this stuff to work with Git. This is something you do once. This is how you let Git, the Git program, know to add to its configuration file under the user.name, Mike Lippman. You can go and find this configuration file on the system and manually add Mike Lippman to it if you'd like. Okay, so did that one. Go back here, grab the second one, paste that in there. Change the email address. All right, so this sets the variable user.email. Done. Good enough. All right, so we only had to ever do that one time. All right, now the next thing I'm going to do is I'm going to go to creating a repository. Okay, so this is something we do in GitHub. GitHub is the Git repository for us. Okay, so we're going to go into GitHub, which I'm actually, we'll just use this. Here we go. Go to this guy. So I'm going to go to this create new up here. I'm going to create a new repository. Okay, and we're going to call this guy CSC 300 linked list. Fair enough? And as I make updates, I'll submit these updates to this one repository. Okay? And here for description, which is optional, you know, our linked list implementation for CSC 300. Okay? I'll go ahead and make this public so anyone can see this. And then you can choose who can see, or you can make it private, but if you do this, you have to pay. They don't let you do private ones without paying. So we'll keep it as public. You can say initialize it with a README. It's not important. The README tells people how to use it, how to use the Git repository. I'm telling you that now. Okay? And you can also add a license if you want. So here's all the public licenses that you might choose: the GNU license, the Apache, MIT open source license, we're not licensing our software, right? If somebody decides to take our software and go and use it for their own purposes, we're not going after them. So they don't have to agree to any license when they go and download it. So leave that stuff alone, all right? So I just created a nice little folder in my GitHub account to hold CSC 300 linked list. Okay, created. All right. So now, for quick setup, so if you've done this kind of thing before, you can immediately get to it through this. But we're going to show you the individual commands. So what we're going to do is we're first going to type in git init. So out here, first of all, actually let me do this. This is our current directory. When you say ls-a on the Mac, it shows you all files, even hidden ones. So I'm going to say git init here. And this is initializing an empty Git repository in this directory. Now when I say ls, you don't see anything. But when I say ls-a, notice I have a new folder here called .git. On Unix-based systems, any folder that starts with a period is by default a hidden folder. Doesn't matter to us. For this example, I'm just showing you what happened when we typed git init. If you start having to go into that folder, things have gone very south. Okay? This is just this local hidden folder that the Git tool uses to keep itself sane. That make sense? All right. So for us, we don't care about it. We just care that we've typed in git init, and this guy is now a Git compatible directory. Fair enough? All right. Now, we can say git add for adding different files. We want to add all of our files to this guy. Okay? So we're going to say git, well, actually first let me do git status. Okay? Git status shows us all of the files that are in that directory that are currently not being tracked. Okay? And they'll show up in red on here on a Mac. These are the files that are currently not part of our local Git repository. They happen to live in the same directory, but I haven't added those files to my repository. Okay? Now, I'm going to say git add star. Now it shows that I have added all of the files in this directory to my repository. The local repository. I haven't even talked to GitHub yet. Okay, this is all just local. I'm setting up my folder for local Git. All right. Now, if I didn't want to add all of them, I just wanted to add an individual one, you would have said git add driver.java. Something like that. Okay? But I want all the files in there. Fair enough. Now, I can commit something right here. So I can do commit -m is for a message. And then I can give it the message. So we'll go ahead and type that. So I'm going to say git commit -m initial commit. All right, and it went ahead and it committed those to the my local repository. So not only were they already added to the local repository, now they see, if you look up here, it says changes to be committed. I've told Git up here that I would like to track these files. Now, if I type in git status, notice that it says I'm on the master branch, so the default branch that was created for the original repository, and there's nothing to commit because the working directory is clean. I haven't made changes to any of these files. That make sense? Now, just quickly here, let's just come up here to, here we'll add a comment. Blah, we'll save that, come back out here, notice that driver.java has been modified. Make sense? And it says that these guys need to be committed. So I can say made a change to driver.java. just not happy about something. Changes not staged for commit. Am I skipping a step? Maybe for local, you don't have to commit. I hardly ever work with local ones. Branch master changes not staged for commit. Let's do ll.display again. Maybe you don't have to commit to local repositories. It's just happening on its own. That's got to be it. That has to be that's the only reason this could be happening. I don't typically work with local ones. So in any case, this is how we do stuff locally. We don't really care about that. Let the local thing deal with itself because it seems like it already does. But what we want to do is we want to add this guy to our remote GitHub account. Okay? So I'm going to go ahead and copy this line. So this is saying git remote add. So we're not doing a local directory. We're adding it remotely to, and typically you call it origin. This is more of a naming convention thing for your original remote GitHub add. Here's the place where we're adding it. So this is the link to your repository you've created for CSC 300 linked list. Okay, so we'll go ahead and steal this line. We'll put it in here. And now it's going to want us to log into GitHub. Won't it want us to log into GitHub? Or have I already logged into GitHub here before? I bet you that's it. Oh, maybe this is where it actually pushes up there. Yeah, that's it. So we added it. This is adding to our local Git that we would like to have this guy controlled by a remote location, and this is the remote Git it's going to be managed by. Now we have to tell it our username for GitHub. My username for GitHub is. It's actually an excellent question. So just that? I don't think that was my username though. Just so I don't screw this up the first time. Let me, here, I'll sign out. Yeah, let me sign in. Is it saving it? Yeah, awesomefat at Gmail. All right, so awesomefat at gmail.com. And then password. All right, so you type in your password. Notice it's trying to do its thing. Talks about compression and crap. Rating objects, blah, blah, blah. Now I've put it up there on GitHub. To show you what just happened, I'll go ahead and sign in. If I go to my repositories, notice I have 3 files in my repository here. Here's driver. Here's linked list. and here's node. And if somebody ever wanted to check out, well, first of all, you can see different branches, but right now we only have a single branch here. So this shows you all the files. You can click on any of them very quickly. Typically, let's see, where's the download? Okay, here. Yeah, so if you have a repository, you can download it as a zip or you can clone it to your desktop. This actually uses the git command, but in any case, this is a convenient way for somebody to download your software. But for me, I want to be able to go to this link right here. Notice that the link it gives me is github.com/mlitman/ the name of my repository. Okay, so for Nick here, it might be github.com/nlargen/csc300 link list, something like that. So what I want you to start doing is when you turn in your homework, just give me that link to where I can find your current GitHub code. Make it easier for me to grade, and you won't have to attach as many documents. Just paste that link in there. Make sense? All right. Now, let's go ahead and make a change to our document. Let's go into driver here. So we see that driver, the current thing says ll.display. That's an older version of it, right? All right, so that's saved. So now we're back to the other problem. Git status. Okay, it's showing that this guy is modified. I don't think we need to do git add star. Oh, we do. I guess that makes sense. If you have a modified file and you want to add it to the repository as a modified file, you have to still say add. Then you can say git commit. Oh, it's asking us for the message because I didn't do the -m, whatever. So I'm going to say made. Actually, this is using. Made a change to driver.java. Okay, so made a change to driver.java. One file was changed. There was 2 insertions because I actually had made 2 changes there before because I took that comment out. Now let's see, did that update it in the cloud too or just the local copy? Come back to my repository here. Looks like it was just the local copy. So now I need to do the git push origin master. So this should add, actually use that, did that add it? Yeah, there it goes. So that put my, that committed any of my local changes up to the cloud. So now driver.java, it shows this is the last version of that. If I click on driver.java here, we can look at history. And we should see, here's the 2 different versions of it. Here's the initial commit of that, and then here's the thing where I made changes to driver.java. And it even shows me what changes I made. That make sense? You can look at a split view. This shows you the original, this shows you the new one. You can see the only change that's in here is this ll.display as well as a blank line. That make sense? If you want to see what they would look like if they got merged, you can say unified. Now this brings those 2 files together. Giving you your final version. But at any point in time, since you only have 1 committer here, you don't actually have to do merges. So it's all us. We just see our old files. All right. So that is Git from the command line, and the instructions for doing that you can follow at from GitHub's main website. So set up Git, create a repository. You can fork a repository, which creates a secondary branch, and you can do all this from the the command line. Not something we would probably be doing in here because we don't have beta versions and release versions of our code, that kind of stuff. All right, so now let's look at Git for Eclipse. Now before we look at this plugin, I want to see if it, since Eclipse is doing a local Git repository, do they have a tool built into it for handling Git? I don't think they do. I think the local thing is just for its own sanity. It's using a local repository. Okay, yeah, it doesn't look like it. So what I did here is I just did a search for Eclipse GitHub, and it brings up eclipse.github.io. It's a plugin for Eclipse for supporting GitHub. So we're going to go ahead and we're going to click on download eGit for eclipse.org. So that takes us right here. And let's see. We'll click on the main update site. So we're going to enter the update site location up here, and I'll show you how to get to that install page. So the update, does it give me it up here? Let me just grab this. So I'm going to copy that link. We'll go into Eclipse. We go into Window. Is it Window? Help. Help. Help is we're going to install new software under the Help menu. So this allows us to put plugins in here. Then we were going to type in the site where the plugin is located. All right, so I typed in the link from that page. So we get something called the Eclipse Git Team Provider and also JGit. So these are two plugins for it. We'll just select them both. Go ahead and hit next. And it's giving us several different things we can work with within Eclipse. And you notice that we have a Java implementation of Git that's getting created for us. So the Eclipse can actually run this internally in the tool. Just keep hitting next, accept anything, of course read everything that ever gets thrown in front of you. Alright, so it's going to install this software. So Eclipse kind of works like Chrome in that there's a whole bunch of plugins for it. Okay, so that's one of the advantages of using Eclipse for your Java development, that there's already existing plugins for this tool because it is the industry standard. All right, so you will now need to restart Eclipse for the changes to take effect. Do you want to restart it now? Sure. Okay, this is an Android error. That's not anything related to Eclipse, or to Git rather. Okay, so now that we've done that, does it tell us how to use it? Documentation, user's guide. Okay, so let's see, where's the menu for doing this? Preferences, team, Git, configuration. So I'm just going to take you through some of the things we've already done. So under the Eclipse menu, click Preferences. Under Team. So Team, then Git, configuration. Notice I've already, since I did these in the command line, they're already there. But you can add an entry, put in user.name, and then your value, just like we did at the command line. Okay. But my two are already there because it recognizes that I have a .git directory in there already. Okay. So this is I'm just going to leave the rest of the stuff alone. Was it already in Eclipse before I did this? Okay. I just didn't even check in there. All right. So we do the identifying thing, username and email. Okay.
Was that in there already?
It was for me because I had done it from the command line. Yeah. The Git repository that I created it manually from the command line already. Yours will be created when you do these couple of steps.
So we don't need to do that command line stuff.
You don't need to do the command line stuff. This replaces the command line. In theory. Like I said, I've never used this tool. But I would think Git's pretty popular. It's probably going to work. Okay? Yeah, you don't have to touch the command line. I just wanted to show you how Git is usually handled. Okay, so we have our project. We added it. Already went up to GitHub and did the stuff there. This is talking about specifically for Windows 7. You have to add an environment variable for home that makes sure that Git is in your environment. So follow these instructions on Windows. For the Mac, Git's already installed. So you don't have to worry about that. Okay, creating a repository. So in our workspace, we do that. Where's the share file, team, share project? So let's go to here, file. Do you see a team?
It was.
It was a team? Let's just look a little farther down the documentation. It's possible this one, are any of you following along? Is there a team folder under file? I didn't know if mine wasn't there because I've already shared it. Let's go into preferences, Git. So here's the default repository directory. So this is where it's keeping I didn't type anything in there. That's what it was already set to. White space. We can have it store our credentials in a secure store by default. I'll go ahead and check that. So when we finally do figure out how to commit it to GitHub, it'll work. So let's hit apply there. Committing. Configuration. All right. Let's see. Can we do this maybe? Click on the project. Go to File. Do we have a team now?
Yeah. You right click it.
Oh, you got to right click on the project?
And it'll show up on
There we go. So actually what I'm going to do, just to see if this is the case, I'm going to right click on source. Yeah, we got a team there. Because you probably don't want to share your whole project up there because that's going to also upload the JRE, the Java Runtime Environment, which that's a standard common thing. That's not something you wrote. So really you want to commit your source directory. So we'll right click on that. We'll hit team. We'll hit, well, do we want to apply patch?
If you do the share, it comes up with the Git option.
Under team?
Yeah, under team. And, you can't share. Oh, I can't on mine.
Yeah, it's probably because I've already added it. Okay, so let's assume here, let's just see it on another example. So I'll right click on this guy, team. No, can't do it there either. It's weird.
I think to share the project, you have to do it at the project level.
I think I just tried that. No, you're right. You're right.
Well, that's what you said, but you said the GRE thing.
Yeah.
Well, yeah, but I was thinking that if you share this project, it's going to put all this stuff with it. But let's find out. So right click on that, share a project. We're going to do it on Get. Hit next. And we're going to tell it where our repository is.
So would you put the URL in?
I would think so. Let's say create. So this looks like.
I created a new folder, just like name it CSA 300, and then it did it. And now when I look at the team, I have like a whole bunch of options for commit. And
Okay. So we'll just do configure Git repository. We're going to go ahead and create it in the same place it was at
On this then.
before. So I'll hit the. Oh, creation of repositories in the Eclipse workspace is not recommended. So they want us to choose a.
This.
Determine a directory for the new repository. It doesn't like this. Let's go to. I'll just do it on Dropbox. All right. So I selected my Dropbox directory just to store my Git repository. We'll hit finish. All right, so now you're saying if I right click on this and I go to team, we got a bunch of options now. So we can choose to push. Let me just quickly make a change. So we'll add a comment here for Bob. I think maybe creating that repository did something funny. All right, fine. So I made a change to driver. Let's go back to team, just real quick. Let's push. It didn't do what I wanted to do. I want to
Did you
get
use
it.
the URL in? You got to push.
Well, it didn't ask me for anything.
Oh, yours name didn't pop up.
yeah, we got.
I got something that popped up.
Maybe because I already have a Git directory in there. Let's just look up here real quick. But in any case, what I want you to do for homework for Tuesday is take your existing project, get it up on GitHub, one way or another, either using the command line that I showed you or using this plugin, and then submit the link to your GitHub thing. So you don't have to do anything else to your code. I'm not even going to grade the code. I just want to see that your current project is up there. Okay? Now you might want to bring your project up to date with ours from class, but go ahead and get your project up there on. So create a GitHub account, get your project up there, provide me a link so I can see that your code is on GitHub and you now know how to submit homework from this point forward. Make sense? Yeah, I'll put that up on Angel. I'll see everybody on Tuesday.
I like being able to reference back to your code too, which I missed.
Yeah, my code will always be up there.
Had I had that, I
You got it? So what was the here? I'll keep the video rolling here.
I had something seriously messed up with my code.
How did you get it to work?
I went to push, and then did you create your get account?
Let's see if this works. I just committed my changes.
Yeah, no, I forgot to put anti-gel in my tank last night when I filled it up. My fuel was about half gelled up. Did not want to start.
So is Eclipse just crashing now?
I click on that one.